Hi guys, I am Sarvesh and today I am going to cover the topic deep learning. I am just going to cover the basic of deep learning in this lecture to make an intuition. So let me proceed further. What is this deep learning? Actually, this is also a part of this machine learning technique. Here we try to teach the computer how to mimic the behavior of human beings. Like human brain, just try to learn something from experience and just try to revert back on that scenario, on that condition according to their experience. In the same manner, we try to teach the computers how to mimic the behavior of human beings' brain. So let me proceed further. Why deep learning? The next question comes, why deep learning? Actually, nowadays, deep learning is getting lots of attention lately, and here is a good reason for this. Like, we are using driverless cars, we are just enabling them to recognize the stop sign, distinguish the pedestrian from a lamp post, and these all are possible with the help of deep learning techniques. Here, our computer tried to learn, our system tried to learn from experience and just try to implement those learnings. So we can say automation is going to be very far in a very faster manner with help of this deep learning, and we are just making more efficient automated process with help of deep learning techniques. How this deep learning network is built, deep learning systems are built. Deep learning networks are mainly based on neural networks architectures. So generally we used to say this deep learning as deep neural networks. Actually, for a neural network is combination of neurons, input associated with this, weight associated with this, bias associated with this, and few activation functions which is used according to the output and input relationship. Here, deep term is involved with this deep neural networks because here we are including more hidden layers of neural networks connected with each others. So we used to say this deep neural network. Here you can see an example of this network. We are giving input to our neurons. Few hidden layers are involved here, and we are getting output from output layers. So let me proceed further. What is this neural network? Actually, neural network is connected network that takes input and computes the desired output. This we can say a neural network. Here we are giving input, few hidden layers are used, and finally we are getting output. Components of neural network is considered input layer, this one, first layer, hidden layer, these are output layer, weight and bias, and activation function. These are the main components of this neural network. What is this input layer? The first layer where we give input. What are these hidden layers? The layer after first layer is called hidden layers. Actually, hidden layers are one or more in number for a neural network. And what is this output layer? The last layer where we get the result. This is the output layer. Here you can see this is the output layer. And weights and biases. Weights control the signal between two neurons. In other words, a weight decides how much influence the input will have on the output, how our output is related with our input. According to that, we try to get the weights. Biases, these are constant. Few constant are added as an additional input in the next layer that will always have the value of 1. Bias unit are not influenced by the previous layer, but they don't have outgoing connections with their own weights. The bias unit guarantees that even when all the inputs are zeros, there will still be an activation in the neuron. So few biases are added for this purpose, few constants are added. And now, what is this activation function? This is the mathematical function. We can use any activation function. Few lists of activation functions are with us. We can use any activation function according to the relationship between our input and output. It normalizes our input and produces our output. If we are not using activation function, then what will happen here? Actually, we will not use this activation function. Then we will get input as output because there will be a linear relationship. We try to normalize our input so we can get non-linear relationships, so we can get desired output. So activation functions are used according to the requirements. And what is this loss function? Actually, this loss function is main important component where we try to minimize this loss. Actually, this is the error term, and we try to minimize this. With the help of this loss function, we just analyze the efficiency of our neural network, and we try to optimize our solution. And here, last term comes here is back propagation. Before moving to the back propagation, let us discuss about feed-forward neural network. Actually, in feed-forward neural network, just the normal flow of our neural network, like we are giving input, weights, and biases are associated with it, and it goes through the hidden layers, and the last there is an output layer where we are getting output after passing it through the activation functions. In the same manner, when we try to analyze our result, whether this is the optimal result or not, we try to go backward. We try to analyze our error, that loss function or cost function, whatever you can say it, loss function or cost function. And according to the error, we try to just control our weights, and we try to pick the optimal result according to the low error. So this back propagation is the main important part where we try to optimize our solution. I hope you got a clear-cut basic idea about a neural network, how this neural network is formed, and what is this deep learning. When we are increasing the number of hidden layers, we are using more than 150 or 200 hidden layers, then we can say it as deep learning neural network because we are increasing the hidden layers more and we are getting more accurate results. Main advantage with this deep neural network is that we can get we have not to do data mining in the basic machine learning algorithms. We have to extract our useful features, but with deep neural network it try to analyze the feature importance, and according to that it try to optimize weight and it try to feed it to our architecture. So here it is our job of just data um, feature extraction, data mining. So it is going to ease our job. You know the pain what you get whenever you do this data mining feature extraction process. You try to analyze the importance of that feature. You try to analyze the correlation between those features, and then you try to feed that clean data to our model. But with this deep neural network, all steps are reduced. All data mining, feature extraction steps are reduced. So it is a huge advantage for machine learning model development process. So let us move further and let us make a neural network from scratch so you can get a basic idea about this neural network. Here I am importing this library, import numpy as NP, because this is numpy library where we are importing few numpy libraries. We are importing this numpy package, which is used for to array calculation, vector calculation. So it is necessary. Importing pandas as PD for working with the data frame. I'm importing this PD. And here I am giving input values np dot array 0 0 0 1 1 1 1 0, and we are just trying to analyze what is the shape of this input values. Here you can see here the 4 cross 2 matrix is taken, and I have given few input. So just labeling this data set, giving some output for testing purpose, for training purpose, sorry, for training purpose. So let me give some output. np.array 0110, and just reshaping it because our input is in the dimension of 4 cross 2. So it is necessary to just keep same dimension of 4 number of rows, because we know that how multiplication can work efficiently with this. So here number of rows should be equal, because for those number of rows we are labeling our this data set. So this output dot shape is 4 cross 1, so we are good to go with this input and output data set. Here giving some weight 0.1 0.2, and then adding few constant as bias. And I am taking an activation function as sigmoid activation function. What is the formula of this sigmoid activation function? This is 1 upon 1 plus n exponential of minus x. This exponential function is under this NP library, which I imported just earlier. So write down this in this manner, a function sigmoid, which is returning this 1 upon 1 plus np dot exponential of minus x. Here, and now I am just taking derivative of this sigmoid. When we take derivative of this sigmoid with respect to x, then you will get this function sigmoid of x into 1 minus sigmoid of x. Here, for epochs in 10,000, for 10,000 epochs, 10,000 number of iterations, I am just going to train my model. So let me show you further. For epochs in 10,000, weighted sum is equal to np dot dot input weights plus bias. This dot function is under this np library, so we are using this np in weights and weights. This is the input value, because we are giving few input. So here this is not weight, something wrong. What was input? That this was the input value. So here write down this input value. Input value, sorry, and weights plus bias. And let me demonstrate the code further. First output equal to sigmoid weighted sum. Here we are taking weighted sum, that is the wx plus v. W is the weight associated with that input, and this bias is some constant. And now we are passing through an activation function sigmoid. So our first output will be this sigmoid. Then we will try to do back propagation. Here we are trying to just find out the error term. First output minus output. What was our output given? This one. It tried to analyze it. And error term, then we are just going to get total error for all number of inputs, and we are trying to get the mean of those. And now our first derivative is this error term. Second derivative is the derivative of this first output, and finally we are taking derivative as first derivative error term, and second derivative of our first output. And we are giving the final derivative as t input and derivative. What is this t input? T input is the input value transpose of this input value, and here derivative. Just we are multiplying this t input transpose of our input values to our derivative term, and we are updating our weights again. And here we are taking this learning rate as alpha equal to 0.05 and multiplying it with final derivative. For I in derivative, bias is equal to bias minus 0.05 into I. We are updating our bias also, and we try to get the optimal weights and biases. So let me show you the demo, what we are getting from here. This minus 0.42, this 8.98 minus 4.19. These all are the weights and biases associated. Weights are from here. We are getting this final weight. Biases, we are getting this bias. And we are getting this weight. So this is the final bias value, what we are getting. And this is the final weight. And now let me move further. Let me do the prediction of this. What is the prediction of this input? If we are giving input 0, we are giving input 1. Result, we are just multiplying our input with our weights and bias. And here we are getting result after passing it through sigmoid function, and we are just printing the result. This is 0.99. So for 0, 1, let us check what should be the output. From here, for this 0, 1, for this second input, what was the output? The output was 1. For this 0, 1, our output was 1. Here we are getting output as 0.99. So you can see it here, how accurate our prediction is. So we can say neural network is pretty much accurate to do a prediction. It is pretty much efficient model. Thank you.